Lesson 2.2, Direct Variation. You should learn from this video how to write and interpret direct variation equations. This is the graphic organizer that you were given at the end of class today. We're going to use this to list the questions that you'll ask yourself if you are asked if something is a direct variation. If you're given a graph and you're asked if it's a direct variation, you ask yourself, does the graph pass through the origin? If your graph does pass through the origin, then you do have a direct variation. If you're given an equation, you ask yourself two questions. First, is it in the form y equals kx? If it is in the form y equals kx, then you do have a direct variation. If it's not in the form y equals kx, then try to rewrite it as y equals kx. So your next question would be, can it be written in the form y equals kx? If you can rewrite it in that form, then you do have a direct variation. The last way they could give you a relation is with a table or a map. If they give you a table or a map, you ask yourself, is the k constant for each ordered pair? If the k, or the rate of change, is constant for each ordered pair, you do have a direct variation. Okay, the first way we're going to identify whether a function is a direct variation is by looking at the k, the constant of variation. The k is equal to y over x. So all you have to do is divide y by x for each ordered pair and see if it's the same. So first ordered pair is going to be 2 over 1. The second one is going to be 6 over 3, and the third one is going to be 8 over 4. Since each of these reduces to 2, this is a direct variation. So you can say y varies directly with x, and your equation is going to be y equals, because the direct variation is y equals kx, you're going to replace that k with a 2 because that's what your k is in this problem. The second part you're going to do again, take y divided by x. So first point is going to be 4 over 1. The second point is going to be 8 over 2. And the third point is going to be 11 over 3. 11 over 3 does not reduce to 4 like the other two do. So this one's not a direct variation, and you can say y does not vary directly with x. Okay, you can pause it and try this one on your own. You're just going to do, find your k, which is going to be y over x, and if it's the same each time, that's going to be a direct variation. If it's not, then it's not a direct variation. Pause the video and I'll give you the answers in just a second. Okay, so A, if you divide y by x, you get negative 21 over 3, negative 14 over 2, and negative 7 over 1, and they each reduce to negative 7. So my k is negative 7, which means that y does vary directly with x. For the second one, if you divide y by x, you get 5 over 2, 7 over 3, and 13 over 6, which are not the same, so that means that y does not vary directly with x. Okay, identifying direct variation from equations. The direct variation equation is y equals kx. So it has to be written in the form y equals kx, or it has to be able to be written in the form y equals kx. For example, this first one, if I divide by 3 here, I'll get y equals 7/3 x, which is a direct variation, and k is 7/3. B here, if I divide both sides by 7, I get y equals 2x plus 1, which is not a direct variation because of the plus 1 here. So y does not vary directly with x. Okay, pause it and try this one on your own, and then I'll give you the answer in just a second. Okay, the first one, if you rewrite it, it is a direct variation. To rewrite it, you have to move the 5x over by subtracting, and then you have to divide both sides by 3. You get y equals negative 5/3 x. So that's in direct variation form, and the k is negative 5/3. For b, if you just rewrite this, it's x over 9, but you can write it 1/9 x, and now it is in direct variation form, and your k is 1/9. Sometimes you're asked to solve a direct variation. If that's the case, because with a direct variation, y divided by x is constant, that means that you should have a proportion that you could set up, because you could do y over x equals y over x. So it says y varies directly with x. That's your key word that says you can use this proportion. And y is 9 when x is negative 15. So it'll be 9 over negative 15 equals, and then it wants to know what y is when x is 21. So you just set up a proportion, and then you do cross products. So you get negative 15y equals 189. Divide both sides by negative 15. And you get negative 12.6. So your answer is y equals negative 12.6 when x is 21. Alright, so I'm going to try that again. I'm going to do this one. If you want to try it yourself, you can pause it. Because with the direct variation, y over x is constant, you're going to set up a proportion, y divided by x equals y divided by x. So 15 over 3 equals y over 12. And you do cross products. Okay, you can set up an equation like that, like I just showed you, or when you're solving proportions, all you really have to do is multiply the numbers diagonal from one another and divide by the number across from the variable. So if you just take your calculator, you can do 15 times 12 divided by 3, and you get 60. So your answer is 60. Y is 60 when x is 12. Okay, now we're going to use a direct variation to solve a problem. A salesperson's commission varies directly with sales. So Y is commission, sales is X, because they normally say Y varies directly with X. So commission varies directly with sales. You're going to make commission Y and sales X. So we've got $100 in sales, and the commission is $85. I just did that backwards. Sales is X, commission is Y. They want to know what is X, what is Y, when X is 2,300. So we're going to set up our proportion again. Now it's Y over X equals Y over X. So that's going to be 85 over 1,000 equals Y over 2,300. And again, you don't have to set up the equation. You can just multiply here and divide by this one. So 85 times 2,300 divided by 1,000 gives me 195.50. So what is the commission for $2,300 in sales? It's $195.50. Again, you can try this one on your own if you want to. I'm going to go ahead and do it though. Number of calories varies directly with mass of cheese. So it's going to be Y, and mass is going to be X. So 50 grams of cheese contains 200 calories. How many calories are in 70 grams of cheese? So we're going to do Y over X equals Y over X again. And that's going to be 200 over 50 equals Y over 70. And then you just multiply the numbers diagonal from one another and divide by the other number. So that's 200 times 70 divided by 50. So that's 280 calories. Okay, so now we're going to graph direct variation equations. Direct variation equations always go through the origin. So when you graph A here, you can go ahead and put a point on 0. Then you take the number that is your K, and that's your slope. So if it's 3 over 4, that means you're going to rise 3, and you're going to run 4. So up 1, 2, 3 over 4. Put a point there. Again, up from here, 1, 2, 3 over 4, and a point goes out here. Then I'm going to have to stop because I have run out of room. And then you draw your line. Example B, it's a direct variation, so you know for a fact it's going to go through the origin. Put a point on the origin. Then your slope is going to be -2, which is the same thing as -2 over 1. So you're going to fall 2 from your point. You're going to go down 2, and then you're going to run 1. So you're going to put a point here. Then again, you're going to fall 2 and then run 1. So you're going to put another point there. And then you can draw your line. 3 points, you can draw a line. Okay, you can try this on your own. Pause the video and I'll give you the answer in just a second. Okay, here are your graphs. The slope for the first one is -2 over 3, so it's going to go down 2, right 3, down 2, right 3. The slope for the second one is -2, so it's going to go down 2, right 1, down 2, right 1, down 2, right 1. Okay, this is where you do it on your own. I want you to give me the equation for number 1. So you're going to find y over x, and that's your constant of variation. And then for 2 and 3, I just want you to tell me what k is in your equation.